am delighted to talk about this topic. It's one of those areas that is near and dear to my heart. It's something that I spend a lot of my time thinking about. And as Kate said as well, my name is Michael Carducci. I live somewhere in the intersection between magic and technology. I call myself a holistic software architect because I feel there are so many different facets and dimensions to this field that you have to consider all of them in all of the various contexts. And the same is true of APIs. I have a book, if you want to learn more. See my friends right over there, in fact, at the A-Press booth in booth 17. That is coming out a little later on this year. But APIs are definitely an architecturally significant decision, the direction that we go with all of these things. The problem is, I have biases. I have approaches that I prefer. I look at different approaches to APIs and I see the various capabilities that they offer, and just intrinsically in my heart, I just think some of those things are cool even when they don't necessarily matter. But the reality is we all have biases. And if we're going to be effective in what we're doing in designing systems and making these key decisions, these biases have no place in the decisions that we make around anything really in the technology world, especially things that have such farther reaching consequences in terms of what the system can do and how all of these things behave. Now, we live in the wonderful year of 2024. I say wonderful. I don't know if it is. It's all we have. So we're going to go with it. But at this point, there are so many different choices that we have available to us in terms of APIs and integrations and strategies and things like that. And more fundamentally, they all do the same thing. Like at a high level, looking at these things, they all perform the same function. They all allow us to serialize states and send them across the wire. But architecture is more than that. Architecture is the essence of software. It is everything the software can do beyond just the features and functions. You know, you give me a set of features you want to put into an application, I could probably find a near infinite number of ways to code those. But what else does it need to do? And that's the kind of thinking that we need to bring to API strategies. Because fundamentally, every decision we make at the architecture level is a trade-off. Mark Richards, Neil Ford, who you might remember from years past, they codified this in the first law of software architecture, that everything is a trade-off. And in fact, over the years, as they've been saying this, every now and again, people come up to them and say, I've got one. It's not a trade-off. And they would have a conversation about it, and eventually Mark or Richard, or Mark or Neil would say, oh, no, there's your trade-off right here. Oh, yeah, you're right. And so they added a corollary to the first law of software architecture that if you think you have identified a decision in architecture that's not a trade-off, it is. You just haven't identified the trade-off yet. And trade-offs are everywhere. I'm going to give you an example of a trade-off. This is not the current generation, a previous generation of the iMac. And they made a very significant decision in the design of this machine. Basically, everything in this very powerful, very capable system had to fit within this impossibly small bezel. It needed to look like that. And so they made a decision that they were prioritizing an integrated architecture where every single thing in that system is tightly coupled, and that it is hard to change any component of that system without changing everything. And on the one hand, we get a beautiful machine. Like, objectively, this is a marvel of engineering. But at the same time, you cannot change that machine. If you bought that machine and you decided, you know what, I got the 512 gigabyte solid state, I really wish I had the 1024, the terabyte drive, you're buying a new machine. That's it. You cannot change that. If you got 16 gigs of RAM, and then you start realizing that your entire developer tool set and everything else, 32 or 64 would be a little bit better. You cannot just slot in a new DIMM. You buy an entirely new machine. You got the 21-inch, you wish you got the 27-inch, you're buying an entirely new machine. So it is a set of optimizations that give us something wonderful, but at a very high cost. Now contrast that with the modular, it's a design trade-off. Contrast that with the modular kind of tower-style PC. Not to brag, but that's actually my PC at home. I'm not really a gamer, and in fact, I didn't ever anticipate buying a lot of that, but I like pretty things. And so I appreciate that there are so many options to choose from in doing this. But this is the style of PC that I have in my home right now, and they chose a very different approach. They chose a modular architecture where I could take any individual component, plug one in, plug another one in, swap it out, and I've done that. This machine right here, I've changed the design, I've changed the actual case, the chassis, twice. I've upgraded the RAM a couple of times. I've upgraded the cooling twice. I've upgraded the graphics card. I've upgraded the processor, which meant upgrading a motherboard, which basically means that that is the ship of Theseus of computers right now, because I don't think there are any original parts anymore. But I valued that capability to be able to evolve the system over time. And again, there are trade-offs. On the one hand, it is much bigger. It consumes much more power. It is much noisier. But I get this evolvability. I get this upgradability. I get this adaptability. I get these ilities. And it does come at the cost of efficiency in a lot of places. And I think we see some of these things all the time. And so when I start thinking about APIs, usually we start thinking about APIs from a single case. We're building a React or an Angular or Vue or a Svelte or whatever front end. And we need some way for that application to talk to the back end, to go and get data, do authentication, do all of these things. And a lot of these APIs start to morph. Or every now and again, we'll build little ad hoc interfaces inside of our applications to do some administrative type of things or back-end type of things, or maybe this microservice is going to talk to that microservice, and we've got a little private back channel. But something more interesting started to happen in software. Because over the years, we would build these information silos. And we would build a silo for our accounting in the organization, or for HR, or for inventory, or for whatever. And we would build these little silos, and we would scatter the organization's data across all of these. And as the needs of the enterprise started to evolve, we realized that the answers to our questions are scattered again across all of those silos. And we need some way to connect this. Wouldn't it be nice if in our HR system, if we terminate an employee, we can look into that and we can start to shut off other accounts or do other things or change the payroll and start to connect those systems. And so bit by bit, organizations have started to realize that this integratability of an application is key. And maybe you built an API just for that front end. Maybe you built an API just for a couple of ad hoc things. But if you are not careful and you are in the coffee room one day having coffee or tea, a good masala chai, and you say, oh, well, yeah, I can add another endpoint to the API to make that happen, and a marketing person happens to be walking by, API? And before you get back to your desk, API is now featured prominently on all the marketing materials. It's in the feature matrix, and they are exposing that API to the customers, and it is horrifying because it is not something we designed. And so one of the things we have to think about is not just the first case of an API. We have a choice. We can build that back end and then build a more broad-scoped, long-lived, evolvable, better abstracted API in the future, Or we can build a bunch of these backends for the front end. We've got a front end here. We're going to build a backend for that, and everything is tightly coupled like the iMac. And we're going to build another one for another component. Maybe it's a mobile application. We're going to build another one for some other thing, and we might build another one again. These are options. Or we could take that modular approach and build one thing with a set of standard interfaces that are not going to change radically over the years, so that over the life of that system, it can evolve over time. So we have to ask these questions. Would the business benefit from more than just a back end? When we look at the evolution of software over the years, when I started out, I talked about this yesterday in the keynote, I learned to program on an Apple II. My first language was AppleSoft Basic. And I would just write these long programs, these long linear programs, long listings of code. And it was just one file, one sequential run, other than, some go-tos and go-subs. If I was feeling very clean codey, I would use go-sub. But eventually, our notions of software development got to a point of abstraction where we could break everything up into this more modular type of approach. We had these code modules. And at this point, it was a whole lot easier to think about how we were going to execute code across modules. Everything was sort of in one compiled package. We had these different modules. We would compile them and link them. We would link them at compile time. And if I wanted to call code from one module to another, I would just do it. I would say call module dot or module arrow or module, whatever the syntax is in your language. I would just call that code. And another thing would come out of this. If I ever made a breaking change, let's say here, then all I would have to, I had a lot of visibility into that. And so all I have to do is make the corresponding change here, and I can go on with my life. Right? This is a very natural way to think about code invocation. This is sort of our default. It's very compatible with the models that we use every day. But over time, we started dynamically linking modules. And a lot of these dynamic modules, these third-party libraries, were closed source. And we didn't have a lot of visibility into there. And we wanted this independent evolvability, that the module could evolve over time, and my code could evolve over time, and they could have independent evolvability paths. And so this is where we started to embrace this idea of an application programming interface as an abstraction, some kind of barrier between the implementation of the code and anybody who's going to interact with it. The idea is this would be stable. We would put a lot of design into this part. And so if we did this right and designed this well, we could change anything beyond that barrier with very little impact to the rest of the application. And in theory, this would give us a little bit more loose coupling. And that is often, but not always, a desirable thing in terms of APIs. So when we think about the capabilities of an API and a strategy, there are different things that we might be interested in. We might be interested in evolvability, or abstraction, or performance, or network efficiency, or speed to market, or simplicity, or just the tooling. How easy is it to adopt this approach? But we have to choose what's important. So we're building an API right now. Which one is the most important? If you had to pick, what would you say is the most important on that list? Exactly. It depends. And that's the key thing. Because certainly you look at one approach of APIs and somebody will say, that's not a good approach because I am over-fetching data, or I'm over-posting changes, or the payload is larger than it needs to be. Could we make that payload smaller? Or we need to be able to change the API over time without breaking the thousands or the tens of thousands or the hundreds of thousands of clients that are integrating with that. Or maybe there really is just one. And if there really is just one, and there will probably only be just one, and we control the client and the server, evolvability is probably not that big of a deal. Abstraction is probably going to get in the way, because that abstraction is going to decrease efficiency because we're trying to generalize that interface. But when there's going to be more than one client, and clients that you don't necessarily control, and will have different release cycles, then all of a sudden, maybe we'll trade a little bit of performance and network efficiency for that evolvability and abstraction. Maybe we'll spend a little more time designing it to get those capabilities. But you nailed it. The answer ultimately is it depends. So let's evaluate these as we look at a couple of strategies. I'm borrowing the star rating model, the idea that Mark Richards and Neil Ford kind of introduced in a lot of their talks over the years and their 2020 book, Fundamentals of Software Architecture. And we're going to look at these. But the fundamental question to ask, if you're taking that architectural approach to API choices and API design and API strategy, is this question right here. Who is your customer, and what kind of experience do you want to give them? Because even though we think about an API as being a machine endpoint, which is not always the case, but we think about APIs being a machine endpoint, we have to remember software serves people. And there are people involved in that process. And so who are those people, and what kind of experience do you want to give them? So as we started to build distributed systems, back in the 70s and 80s, we got our first client-server architectures. We had that basic mental model of what we want to do. My code is here, the code I want to call is over there. So I'm just going to make that call, except in this case, it was a remote procedure call. And that introduced some challenges, because one of the recurring trends that we see in API strategies is I want to be able to call code over the wire the same way that I call code over the stack. And those two things are not the same. Those two things will never be the same. Because as soon as you are going over the wire, now you have to deal with the 7 fallacies of distributed computing. The lies that we tell ourselves to make believe that what we're trying to do is easier than it really is. And I'm going to try to go off memory here. I'm probably going to fail. I'm already regretting saying this because now I'm committed. What are the 7 fallacies? They are the network is reliable, that latency is 0, that bandwidth is infinite, that the network topology doesn't change, that there is only one administrator, that the network is secure, and one more. All right, I guess none of us know what the last one is, so I feel a little bit better. But we can't pretend that those are the same. But we tried to do this. So we came up with all these glorious, wonderful ways to invoke code over the network and pretend that we're making local calls. We got CORBA. Anybody remember that? Yeah. Anybody remember it fondly? Wow, I was silent. Everybody sat very still when I said that. It's like, anybody remember CORBA? Yeah. Anybody remember it fondly? No. DCOM? Any DCOM people in the house? Okay, yeah. Fondly? No. So we tried to come up with all these little tools that would allow us to do this. But here's one fundamental problem. If we're not thinking about that abstraction, if I just want to call the code over here, just like it's the code over here, or the code over there like it's the code over here, there's not a lot of abstraction in that. I'm just calling a method. And method signatures evolve over time. We change what the methods are in the implementation over time. And so one of the things we're doing is we're trying to pretend that we don't have to deal with the fallacies of distributed computing. The other thing that we're doing is we're trying not to spend a lot of time designing these abstractions. So typically, remote procedure calls are very tightly coupled. It's like the way that the solid state drive is literally soldered to the motherboard on that iMac. We are just plugging those two things together. Maybe we were designing a custom SSD chip to fit into this particular weird shaped spot that we have for it on the motherboard, right? But you do get certain efficiencies elsewhere. It does always start to add up. So when we look at this with the remote procedure call, we get a fair amount of network efficiency depending on how well we think about the approach, because we are creating a back-end endpoint for a specific function I want to execute. And so we get some efficiency there. But because there's little abstraction in there, because I am actually coupled to the implementation on both sides, my evolvability is terrible. It's not great. Now, these don't take long to design. I already have the code on my back-end application. I just need to wrap it, turn it into an endpoint. I can decorate it with Spring or .NET. Boom, now it's an endpoint. So I can put these things out very quickly, and I can even document them very well with a lot of the tools around OpenAPI and things like that. But we have very little abstraction. Performance is typically very good, as good as it can be in terms of a network call. Tooling in pure RPC is not great. And then finally, in terms of simplicity, it's not the most simple thing we can do. It's not the hardest thing that we can do. It kind of sits somewhere in the middle. Now, as we were doing this, as we were trying to figure out the best way to approach RPC, one thing that started to take off in the late 1990s was this idea of XML RPC. That we would not just, we would standardize on the serialization using XML, and we would standardize in terms of how we're describing these endpoints with XML, and we ended up here. How many people remember SOAP? Yeah, oh, a lot of hands. Okay, fondly. Yeah. Web services, quote unquote web services. Now, interesting things came out of this because we had, for the first time, a way to put a lot of the details of this API in a standardized way in band. And I remember it was about 2001, 2002, something like that. I went to some training. The company I was working for at the time, it was in the Microsoft space, and the .NET framework was starting to emerge. And they were showing us all the new wonderful things that are standard in .NET. And they said, here's how you hook up web services. There's your WSDL over there, WSDL, the web services description language, and you just point your IDE to that file, that giant abomination of an XML vomit, tag vomit. Seriously, if you don't ever look at one of them, your eyes will fall out. But you pointed at that, and then your IDE is, your fan's going to spin up, your CPU is going to get pegged at 100% for about 3 minutes, and before you know it, your IDE is going to generate about 30,000 lines of code, but all you really care about is these little endpoints now. And now you've got these little local endpoints, and again, we can pretend that my calls across the wire are the same as calls inside of my code. I don't even have to think about it. And that 30,000 lines of scaffold that got generated would take care of the rest, and it would kind of work. I don't know why they called them, I do know why they called them web services. And it's not because they learned anything from the web. Like, the web has a lot of interesting lessons to teach architecturally. The reason they called them web services, and I'm starting to date myself a little bit now at how old I really am, but when we were building these distributed systems back in the day and trying to do RPC kind of invocation over the wire, there was a big problem. And the problem was half the time, the code didn't work. And we would test everything religiously. We would deploy it to the client site, and they would say, hey, the application's not working. And we would scramble for about half a day, and then we'd realize, what ports are open on your firewall? Oh, that was it. And then they open the ports and then it all starts working again. And so the only web thing about SOAP was it used port 80. Because who needs SSL? I mean, now they did eventually start using port 443 for secure connections, but it was port 80. That port's already kind of allowed in your firewall. It's all good. And that was sort of what we did. So everybody pretty much abandoned SOAP around 2007, thereabout, 2006, 2007, for a lot of good reasons. Because fundamentally, we took the same RPC style of approach, It was heavy-handed, it was complex. If you wanted to work with it effectively, you needed to understand a bunch of interrelated XML specifications. And I will say this, reading XML specifications, it's excellent bedtime reading. Like, you won't have insomnia. This is what I should have done when I landed a couple of days ago when I had jet lag and it was 2 o'clock in the morning, and of course it's 2 o'clock in the afternoon in my heart. So I should have just gone back and read some of these things. But XML suffered with a lot of the same problems, except it was slightly worse, because now we tried to apply this general interface, so we reduced network efficiency. We standardized on XML as a serialization format, which XML is famously svelte in terms of the payload sizes. So not very efficient, not very evolvable because of the same things with RPC and evolvability and tight coupling like that. Speed to market was not bad. It was pretty easy to stand these things up. We got a little bit of abstraction, especially with the WSDL. Performance was so-so. The tooling, depending on where you are, could be good, could be bad. And it was not the easiest thing in the world, not the hardest thing in the world to actually build these things. Now, right around the time that everybody lost interest in SOAP, and even though SOAP and these client-server RPC things we're not really doing those. I talk about those because we are. We are still primarily doing RPC because it's such a natural way to think about how we want systems to talk to each other, because we think in terms of code. As developers, as architects, we don't tend to think in terms of abstractions. Abstractions are hard. It's a lot of work to design them. It's a lot of work to figure out the boundaries, and it's a lot of work to implement them. But if what you need is that evolvability, that's kind of where you get that. And in terms of evolvable, scalable systems, I can't think of anything better than the web. Right? The web has scaled bigger than anything else. And when we talk about web scale, we just say it is capable of getting close to the scale of the web. The web has changed radically since 1993, when it really kind of first went mainstream and was available to all of us. Like, we use it in ways that nobody imagined in the 1990s that we would. And the architecture of the web allowed that. Now, so right around the time that we were losing interest in SOAP as an RPC style approach to talking to APIs, we got interested in REST. And a big part of this was because the way we were building web applications was starting to change. Because we were starting to build these dynamic AJAX-driven applications that were making back-end API calls and fetching some data and doing some things on the client. And there wasn't a lot of web tooling for SOAP, but we learned about the REST architectural style, and that was the architecture of the web. And so maybe if we're building these web applications, they should inherit some of the architectural ideas of the web. So REST really, as defined, has nothing to do with APIs, but we can apply some of these lessons. And this is a big point of contention, by the way, because REST means something different to just about everybody, except Roy Fielding, because he coined the word and he gave a very precise definition. And he spent about the next 10 or 15 years arguing with people on the internet about what REST really means. And it is entertaining to read some of these back and forth where people are telling him what he really meant. No. What you really meant, Roy Fielding, creator of REST, was this, was what I want the world to be. So let's talk a little bit about this, because the REST architectural style fundamentally is defined by 6 constraints: client-server, stateless, cache, layered system, the uniform interface, and the optional code on demand. Okay, client-server, we can do this. Stateless, sure, why not? Cache, okay, we could do that. Layered system, yeah, we get that. But this is really where everything sort of falls down, and everybody kind of ignores this because we have no idea how to apply the code on demand constraint to an API, so we just sort of ignore that. But what is this uniform interface constraint? This is the piece. This is the magic. This is the hard part of REST. Number one is the resource abstraction. That we're not, if I go and type in a URL, like my blog is hosted at sufficiently-advanced.technology. Get it? Yeah. It seemed like a good idea at the time. Sufficiently advanced technology. Now, I might have an entry point in my code that actually runs that blog called get blog home, or get post index, or get post index by page, takes an int of page number, or something like that as a parameter. But my goal, though, when I type that URL into a browser is not to go and run some code, not to go and make a database call, not to warm up a CPU to go and sort things and apply transforms and things like that. My goal is to just get a representation of the state of that resource. And so the web browser doesn't know anything about what a blog is, or what a post is, or anything, or what my search endpoint is, or anything like that. To the web, they're all resources. They're all resources that we identify with a URI, and all the manipulation that we do with that resource is through passing representations back and forth. Everything that we get back and forth is self-describing. We use standard request methods, standard response code, standard headers, and hypermedia as the engine of application state. But this is a radical departure from the default and natural thinking. And I think this is one of the reasons that REST is so hard. The key things are the URIs are identifiers, they're not endpoints. The fact that you can interact over the network is sort of incidental, and it's a result of the URI scheme. But it's not, I don't know, it's one of those things when we're talking about REST, I try not to think in terms of endpoints, I think in terms of resources. And then I'm going to interact with them through part of that uniform interface. So get is a safe, idempotent way to retrieve the current state of a resource. Post is a way to create a new resource. Here's a representation of this new resource that I'm creating. If I do a put operation, as long as I know the URI, I'm doing an upsert operation, and that is idempotent. Versus post that is not. In other words, if I do a post twice, my credit card's going to get charged twice. If I do a put twice, everything is still the same. A patch operation allows us to do a partial update because that's one of the complaints of REST. I don't want to have to send the whole serialization back just to toggle one bit. Patch allows me to say, I'm just toggling this one bit. Delete allows me to request that resource be removed, but the resources are self-describing and the API is self-describing, and that is not easy. But the key principles, like I said, URIs is names for things. URIs don't change even when representation or implementation does. So we're already losing if our URI is .php or .jsp or .do or .whatever. Because now we're connecting that particular implementation to the identity. And so if we change that implementation, we've broken identity and we've unlinked those things, and that's a problem. Another thing is we try not to do things like .xml or .json or .txt in our REST resource identifiers because now we're conflating identity and representation. So when a client kind of makes a request, dereference a URI, we need to give information, not data, and then we include other URIs in there so people can continue to explore related concepts and related things like that. So the idea here is we have that abstraction, we have that thing, and so when I go and ask for something, it's going to go, when I say, hey, get this resource, it's going to come back 200 OK, here it is, and the representation specifically in this case is text HTML, and it sends it back, and my animations are in the wrong order. So this is a fantastic system. It's so efficient it can actually give you a response before you even ask. Patent pending. We'll fix it in post. It's fine. But yeah, so I say get host sufficiently advanced technology, and specifically I want a text HTML representation. It will say 200 OK, content type text HTML, and send that back. And then we have hypermedia as the engine of application state. So we get the HTML back. That's an example of Helios, right? There's links to navigate within the resource. It says, hey, here's the top 5, top 10 posts. And here's a little preview of it. You want to see more? Here's a link. Click on it and you'll go over there. You want to do a search? Here's a form that is telling you how to put together your search request and send it to the server and get your response. And so that's that's what makes the entire system work regardless of how it's implemented, where it works, anything like that. Now, how do you do hypermedia in an API? because HTML is very self-describing, and it tells us all of the things we can do with the resources and how to navigate to the other resources, how to explore this space, how to interact with the entire system without ever needing to write a single line of custom code to interact with that. You just point your browser and everything works because of hypermedia as the engine of application state. This is why almost nobody's ever built a truly RESTful API, because historically there have not been a lot of ways to do that. Now there are a couple of approaches that have emerged over the last decade or so to do this right. This is an example of something called Hydra. And Hydra is a JSON LD vocabulary for describing APIs in an unambiguous way. In the same way, if my HTML says, hey, this is a form that interacts with that endpoint over there and serializes this way and sends the data in this shape, and the browser just like, okay, when you click the submit, this is what it's going to do, that's where it's going to go, we can describe our APIs with the same level of specificity. Yes, thank you. That word, with the same precision. So Hydra is really interesting. I'm actually going to talk about hypermedia tomorrow, and then JSON LD is basically a way to give context to your JSON, because JSON alone really doesn't mean anything. It's just a bunch of decontextualized name value pairs. As a human, I can look at JSON and say, oh, I know what that means. But it doesn't mean anything to a machine, especially not in a way that a browser just knows how to go to any web page on the net and work with it. And JSON LD allows you to put that context in there. So this is JSON. This is JSON LD. It's JSON with context. It's 100% JSON compatible. And in fact, what's really interesting is that in a lot of cases, you can turn your JSON into JSON LD with 0 edits to the payload. And that is really wild. Because as soon as you add this context, I know specifically what I mean by every single one of these terms. Like these identifiers, these are not magic strings anymore. They have clear semantics that are unambiguous. And so taking JSON LD and creating a context just for describing APIs with Hydra, you get something like that. Now, famous competitors, frenemies, I don't know. Google and Apple and Microsoft and Yahoo, 4 companies that you don't think they get together on the holidays and hang out, you know? But they decided that we should really remove some of the ambiguity with data, and if we're going to start working with JSON LD, let's define a common vocabulary that we can all agree to and align with. And so this is schema.org, and this is an example of a vast vocabulary they have defined for a lot of common concepts of the web. And it is a collaboration between these companies. They got together and they said this is probably a good thing. But when we talk about REST as the architecture of the web and how the web works, and we talk about APIs being RESTful, and we realize that I've never had an API that behaves the way the web does, it's not because the only reason there's a difference is because we think there's a difference. But interestingly enough, a lot of people, myself included, are excited about REST. Martinez, this guy, @NamedGraph on X Twitter, said if applications interoperated using a single generic uniform HTTP API, the whole API industry would go away. A data-centric architecture can get us there. And they talk about how if we just built our APIs the way we built the web, like a whole lot of problems would go away. But remember, it's just a trade-off. This is a lot of upfront work, which is way too much if you are only going to have one client, if you control the release cycles of both the client and the server, or you don't mind having 3 different backends for 3 different front ends, or anything else like that. So it is kind of cool, and it does unlock broader integration within the enterprise, massively simplifying how we might think about integrating systems. Like integration problems start to go away. One piece of homework, tonight, read the Data-Centric Manifesto. because this is a lot of people thinking about how do we completely rethink how integration is done. Do we need to write reams and reams of custom code every single time we just want to connect this data to that data? Or can we do the work once and it always just connects? 35 to 65% of an IT organization's budget is just data integration. Every project starts with a giant integration project. Every system, every application starts with a giant integration system. Like, it's a solved problem, according to the Data-Centric Manifesto people. And I've signed it, by the way. I'm on the list. But it's kind of interesting. So I'm not going to spend a lot of time on this, but because your homework is to actually read this stuff. It's on the website. But if you are doing a true REST API, right, that evolvability, you get the same evolvability as the web. You get abstraction because you are designing your abstractions into it. Performance is so-so because you have a general uniform interface, which is going to degrade performance. It's going to degrade network efficiency because we are taking a general approach, not hyper-optimized approach. The tooling for this type of REST API is not mature right now. And it's funny watching this try to change. Because I've been in organizations where we decide to adopt a mature, hypermedia-driven REST API, and a lot of problems start to go away. By the way, did I mention I have biases? I mentioned I had biases, but I do think these are all cool. And we'll go and hire somebody who's actually working on open source tooling. And you're like, hey, you have a lot of experience with this. You're already working on this. Come and join our team and get paid to build this stuff that you think is cool. And then we build them in. Then we show it to the business people. And all of a sudden, the company says, yeah, you need to stop working on that open source library now. But why? Because this is a game changer. This is our secret sauce. We can't have the world using this. And then they say stupid things like, can we patent this? I've been asked this when we start doing this. They're like, this is amazing. Can we patent this? No, you can't patent open standards. I mean, you could try. I don't know. Somebody's got to keep the lawyers paid. Now, this is not how we build REST APIs. And this is why Leonard Richardson, some years ago, created the Richardson maturity model. This is level 3. With JSON, with hypermedia as the engine of application state. This is the pinnacle. This is the glory of REST, as Leonard Richardson calls it. But this is not what we're building. A lot of times, we're building level 2, level 1, or level 0. Humpty Dumpty said, when I use a word, it means exactly what I choose it to mean, nothing more, nothing less. So if we look at a level 3 REST API without the hypermedia, we still get a lot of benefits. Speed to market is terrible. It's a lot of upfront design. The performance is not great. The network efficiency is not great. If those are your priorities, this is a bad place to be. But that evolvability, that abstraction, that is hugely valuable. And that integration as well. Hugely valuable. Now, one of the reasons I don't think we ever build hypermedia APIs is the reality is, this is the best I could go with Soylent Green. Hypermedia is for people. Like, hypermedia is saying, hey, here's a resource and here's what you can do with it. I am scripting interactions with a remote system. I am not giving the user choices in any given moment. So it becomes less valuable there. So maybe we just go level 2, where we're standardizing on the request methods, and we are using stable URIs, but we're not using hypermedia. Okay, we still get a lot of evolvability. In fact, we get a great deal of evolvability if we want that extra piece, that Hydra or Helios or any of that. That's just one more representation type. We just turn on content negotiation so a client can say, hey, give me JSON. Give me JSON LD, give me Hydra, give me HAL, give me XML if, you're a masochist, right? It's just one little detail and you're there, but you've got stable abstraction with identity. You've got stable abstraction with representation. You're designing these resources. So you still get that evolvability. You still get that abstraction. It still takes a lot of time to do this. If speed to market is your thing, this is not where you want to be. Performance, again, overfetching, underfetching, that's still a problem. You can optimize and tune and tweak and do REST expansion and things like that. The tooling is okay. It's not the best in the world. And if we're doing like a level 2, just kind of standard JSON API, similar kinds of scores. But maybe we don't care about the extended verbs. Get and post is good enough for HTML. Get and post is good enough for me. Patch, we don't need no stinking patch. My references don't get any more current. So if you don't standardize, if you have stable URIs, URIs that represent resources and collections of resources and partially resources, we're not doing Hadios, we're not getting affordances, and we're not using all of the verbs, well then, this is a level 1 on the Richardson maturity model. Now we lose a star in evolvability, we lose a star in abstraction, because we're using less and less of the uniform interface. But otherwise, we still get a lot of benefits of REST, and we can getting from level 1 to level 2 is not hard. Getting from level 2 to level 3 is not hard. But maybe we throw it all away. And the only thing I want to keep is JSON and HTTP. But I'm not going to design the resource abstraction. I'm not going to think about these abstractions. Really what I'm going to do is I'm going to do RPC, just like SOAP, just like the old client-server stuff, but over HTTP. And I'm going to use JSON instead of XML. Well, now we're at level 0. And the thing about level 0 is whatever you want it to be. But if you want other people to use and interact with that API, well, then they're going to have to care. And they're going to have to write custom code to interact with that API. So you're a little more efficient in terms of the network. It's pretty easy to build these things. You get a little bit of evolvability, but you without that abstraction, you lose a lot of it. We get a lot of our evolvability in terms of being able to version URIs. So we have API/v1, API/v2. Performance, again, so-so, depending on what we're doing. The tooling is actually great, because we've introduced a lot of problems, and we are developers, and I am the same way. This is not a judgment statement, but I write code until I run into a problem, and then I throw code at the problem. Like, this is what I do. When I started performing professionally as a magician, I found that running a business and keeping track of inquiries and engagements and bookings and contracts and invoices and all of this stuff is a lot of work. So I threw 600,000 lines of code at it, and I built my own kind of booking system and CRM, and now it's a SaaS product, and so I have to worry about that all the time too. But I throw code at problems. We all do. It's like, this is our superpower. So there's a lot of good tooling out there to kind of make this work around gateways and OpenAPI and Swagger and Swashbuckle and all these things. And it's pretty simple to do this because we don't have to design that API. But that simplicity comes at the cost of the evolvability. And there are other hidden costs as well. So when we're when we're using HTTP, but we're not using it the way it was designed, we're just overloading HTTP as a protocol, and we do something like this, where the backend says, hey, 200 okay, and then I don't think you can read this, but it says error, internal server error status 500. Like, that's annoying. And it can be very expensive as well. Actually, here in India a few years ago, there was an issue that I think it was Uber Eats was calling out to a payment processing API. And their philosophy was, even though 200 means it worked, they said, we're going to give a 200 response code every response is going to be a 200 as long as something happened, even if it was an error. And then they would put a message in there that would tell you if it worked or not. And so the way they implemented this code, they would call out to the API. It would say, 200 okay, this was successful. Your process payment request was successful. And then you read inside, it says, CVV failed or invalid unprocessable entity or something like that. And so they just had a little regex that would look for the error message they were expecting. And if it didn't match, good to go. And something changed on the API, but they kept getting 200 responses back. And then eventually, 2 or 3 days later, the Uber Eats people were saying, hey, This is weird. It's lunchtime, and like 3/4 of our stores have opted out of the network temporarily. I wonder why they're doing that. That's why they're doing that. Because the entire country figured out they can get food for free. That nobody is getting charged for anything. And like they were DDoSing the restaurants. It was wonderful. So they were all like opting out and shutting down. So sometimes being precise matters. Another one, get is a safe, meaning there are no side effects to a get operation. And idempotent, which means if you do a get and you're not sure if it worked, you can do it again without worrying about something happening the second time. Safe and idempotent. Now, I told you I built a booking system, and now it's a SaaS product. And now my customers want stuff. I know. And one of the things they're saying, they're like, yeah, we really need like an opt-out thing to like make our emails legally compliant. And I'm like, okay, but you know, this is like not my day job, and I have other things in my life. So I go and as quickly as possible, I go and make an opt-out link. So you click the link, and yeah, what I could do is you click on it and it sends you to a page that says, would you like to opt out? Click here to submit, and then it does a post. Because you can't put a form in an email. You can only put links in an email because we can't have nice things. And I didn't want to do that. That's a lot of extra work. So I just put a link in there, and if you click it, it goes to the endpoint, which immediately opts out the customer. And then one of my customers says to me, they said, hey, so you know, if you click that, it just immediately opts you out. I'm like, yeah, that's what it's supposed to do. Sometimes people just click on it to see what's there. It says opt out. It says unsubscribe. What do you think is there? Could you change the wording so it says to be immediately opted out? Okay. To be immediately opted out. There we go. And then I start getting support tickets. Hey, my emails aren't going to my customers. My customer didn't get my invoice. My customer didn't get my contract. My customer didn't get my proposal. My customer didn't get my check-in email. My customer's not getting my emails. And every time I'd look at them, they were like, yeah, they opted out. Why would they opt out? I don't know. User's gonna user. Know what I mean? It's an ID10T error. Yeah. And after a while, I started to figure out what was really going on. New breed of email firewalls were scanning links. Yeah. An email comes in, it's like, oh, there are hyperlinks in this email. Let's go see what's over there just to make sure there's nothing like malicious at the end of any of those links. I'm just doing a get, and a get is safe. It doesn't have side effects. They were right, I was wrong. Right? So there are hidden costs that go into this as well. Okay, we talked a lot about REST, but I think we have to, because it means so much. It has such a broad definition. Now, a lot of people rightfully aren't excited about REST, right? Designing resource abstractions is a pain. And even if we're doing these RPC styles where we're not designing an abstraction, we're still getting pretty standard payloads back. And what we decided, it was we want network efficiency. I want to go and ask for precisely what I want. And I want to be able to basically, I want to be able to talk to the API like I'm talking to the database. Select A, comma B, comma C from table A, inner join table B. Like, I want to make these precise surgical things. And I remember this. For a couple of years of my career, for about 5 years of my career, I was a DBA. Now, don't hold that against me, because we don't get invited to a lot of parties. You know what DBA stands for, right? It stands for don't bother asking. But yes, you're right. And I remember people would say, oh, yeah, if you want to interact with my system, here's my API, and I go read your API docs, and it's a whole like convoluted curl, pass in my bearer token, and that's a bunch of hooey. I'm just going to go make database calls. And that's what I did. And then a whole bunch of people who are building web applications, fat client, JavaScript, framework-centric web applications, that's all they really want to do. Like, most of the application now is getting centered in the browser in these 3 to 5 million line bundles of React and all the node modules that you can shake a stick at. And sometimes I'm working on some of these things and I run npm install, and like the lights in my house dim just a little bit. But this makes sense, right? When we look at GraphQL, this ability, we get some trade-offs. So we've got some somewhat self-describing in terms of schema, in terms of endpoints. Now, one of the trade-offs is everything is a post operation, which means no caching, nothing is safe, nothing is idempotent, and we have to deal with that. We do get flexible query and mutation interfaces, but we also, again, trade off security and performance. Because in a lot of cases when we're building a GraphQL endpoint, we are basically saying, hey, web browser, that, historically trustworthy computing environment, a web browser, here is the entire DAO. Do whatever you want. And you see people doing things like this. Well, I'm building the internal company HR system. So you log in and you say profile, and it's got your name and your home address and your bank account details and your national identity number or social security number in the US and a lot of other kind of private information. And you go to a different screen, it's the company directory. And that screen goes and says, hey, I want first name, last name, email, phone number, office location. I want those 5 things, and then I'm going to give that to my client, and here you go. Except I can also just open up a console and create a request to say, I want all your information, Raj. Sorry, I'm losing my eyesight. And unless you're specifically putting those controls in place, like these are some of the things that we're doing. But GraphQL, speed to market. Hey, here's my object model, which is my database model. Create a GraphQL schema for that. Boom, done. Hey, I have my API. Network efficiency, ask for exactly what you want. Now we lose a star because we can't cache and we have to be careful with certain things. We get very little abstraction here, but the tooling is fantastic and it's very easy to use. And we get a little bit of evolvability. We don't get web-like evolvability, but how often do we need web-like evolvability? So I actually think GraphQL is interesting. One more I want to talk about. So gRPC is Google's implementation of RPC, and they decided, hey, you know what? We like RPC. We get RPC. Why don't we do some things to make it faster? Put in some tooling. We'll put a faster, a more efficient serialization onto there. And we'll kind of make that available to folks. So I find gRPC to be particularly useful for things like microservices, right? Where I want inter-service communication on the back end. Like I don't find gRPC generally very useful as, hey, here's my API, everybody consume it. A couple things about gRPC. One is that you have to generate a client. You need code generators. You need to generate these clients at compile time. Historically, it has been limited in in what environments and languages you can do this. But when I'm thinking about inter-service communication that is synchronous, that has to be synchronous, and I want this to be fast, because when you're getting into that kind of distributed system, when I make a call over here, that has to make a call over here, that has to make a call over here, and I want this to work, otherwise my entire application is just going to get static. If I want this to work, I want the latency between those service calls to be as narrow as possible. So you use protobuf as a serialization. That's an option. To have some of this tooling around this to make this work pretty well, that is an option. But you see what I'm getting at in terms of conclusions and everything else. You see what I'm getting at ultimately. Like anything, the answer to these questions is it depends. And I'm going to put this up here because like any decision in architecture, there are no absolute right. Let me get out of the way, Well, actually, if you're all taking pictures, I'm going to do this. There are no absolute right or wrong answers. There are only trade-offs. But the key thing about architecture is making the right trade-offs and making these in context. And I'm going to give that just one more second here because I see a lot of flash. The flash is actually going to help. So my phone does that to me all the time. Especially, have you ever done this? You want to take like a sneaky photo, like there's this moment and you're like, oh, nobody's ever going to believe me. Let me just slide, take a photo, and then it's like flash, 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 flash. I think my phone just does that to me. But there are no right or wrong answers. There are only trade-offs. And that's the key thing. That's what we've got to think about. That's what we need to be mindful of. And that's why I love architecture. Because if it were that easy to make these decisions and design these systems, a language model can do it. I like having that additional skill where, as Ken Cousin put it, I'm not just a stochastic parrot, that I am bringing that context and nuance, and it's a valuable place to be, and I think it's got longevity. And so I want to thank you all for joining me this morning. Thank you.